Alright, so we're going to talk about the mole, what is it, how do we use it, and everything else. It is a unit of measurement in chemistry. The definition of a mole is the number equal to the number of carbon atoms in exactly 12 grams of pure carbon-12. And that is Avogadro's number, is the number of particles. So 1 mole is 6.02 times 10 to the 23rd units. And what I mean by units is atoms, molecules, formula units. We'll talk about that a little bit more as we go through. And the way we use the mole is with the molar mass of a given element or compound, and we find that information off of the periodic table. The average atomic mass tells us that information. Here are some fun facts so that you get an idea of exactly how big a mole is. If you had 6.02 times 10 to the 23rd watermelon seeds, the watermelon would have to be larger than the moon. If you have 6.02 times 10 to the 23rd donut holes, that would cover the Earth, the entire Earth, up to 5 miles deep. That many pennies would stack to the moon 7 times, and 6.02 times 10 to the 23rd grains of sand would be more than all of the sand on Miami Beach. So that should give you an idea exactly how big of a number we're talking about. Before we can really get started on this, we have to talk about molar mass. Well, in order to do molar mass, you have to, and the unit for molar mass is your grams per mole. So anytime I ask for molar mass, that's the unit we're going to have. You cannot give me any numbers without units in this unit or any future units through the school year, so make sure you learn what the units are now. First thing you have to do is write the formula correctly. If you can't write the formula correctly, you're not going to get the correct molar mass, and that's going to affect everything that you do. Then once you have the formula written correctly, you're going to multiply the number of each element by the mass off the periodic table, and then you're going to add all that up. So if I wanted to do calcium phosphate, I'd have to write the correct formula for calcium phosphate. So hopefully you got Ca3PO42, that's the correct formula. Then what that means is you've got 3 calciums, and this 2 distributes. So you have 2 times 1 phosphorus, and your 2 times 4, which is 8. So we're going to multiply. We've got 3 calciums, 2 phosphoruses, and 8 oxygens. We've multiplied each of those together. Then we're going to add these 3 numbers up. Those 3 numbers are going to be added up. And so we find out that the molar mass of calcium phosphate is 310.1768 grams per mole. I really don't like any rounding when it comes to your molar mass. We'll talk about the rounding in your answers in just a minute. But give me the molar mass exactly as it would appear off your periodic table. When I'm making keys, those are the numbers I'm using. I'm not rounding anything. Alright, here is kind of a visual. Anytime you're going from, let's start over here, if you're going to go from moles to particles, you'll take whatever number you're given and multiply it by 6.02 times 10 to the 23rd on top, and 1 mole goes on the bottom. If you're coming from particles to moles, you're going to end up multiplying by 1 mole over 6.02 times 10 to the 23rd, and we're going to do some practice problems so it'll make more sense. Again, particles is your atoms, molecules, and formula units. If you're going from moles to grams, you'll take the molar mass off the periodic table over 1 mole. If you're going from grams to moles, you'll have 1 mole over the molar mass. Hopefully you're noticing a trend. Whatever you're wanting goes on top. Whatever you're leaving is on the bottom. And for our gas volume, if we want to find out our gas volume, it's times 22.4 liters at 1 mole. Or if you're going from your gas volume to moles, you have 1 mole on top and 22.4 liters. So that's the visual that is in your notes. So let's do a practice problem. Okay, 1 mole equals the molar mass. How you set that up is based on what you're wanting. What you want goes on top, what you have goes on the bottom. So this question says, if I have 10 grams, it wants to know how many moles. And then we need to know that we're talking about sodium hydroxide. So the first thing you have to do is you have to write the correct formula for sodium hydroxide, which is NaOH. Then what you're going to do is set it up where you have got your 10 grams, that's your given. That goes first. We want to know moles, so we have 1 mole on top, and then the molar mass. This is the molar mass, and yes, I did round for notes purposes. So you have 10 times the 1 divided by 40, and that gives you 0.25 moles of NaOH. Well, if we want to go the opposite way, if I have 0.5 moles of carbon dioxide, I want to know how many grams I have. So moles is my given, and grams is my want. First thing we have to do is write carbon dioxide, because when dealing with grams, you have to have the correct formula in order to do the correct mass. So carbon dioxide is CO2. So then I'm going to set up the problem. I have my 0.5 moles. That's what my given goes first. My molar mass goes on top, because what I want goes on top. So this time I want molar mass over 1 mole. So that's where you have the 44 grams of carbon dioxide over 1 mole carbon dioxide. 0.5 times 44 divided by 1 is 22 grams. And we are going to do some more. We're going to go over this in class, and we're going to do more practice. So that's if you have grams to moles or moles to grams. So we're going to go to the particle side. If you have 0.25 moles of rubidium nitrate and you want to know how many formula units. Formula units is what we call ionic compounds. They are formula units. Covalent compounds are molecules. Elements are atoms. So the process, though, is all the same. You're either multiplying by 6.02 times 10 to the 23rd or dividing by it. Because I gave 0.25 moles of rubidium nitrate, it does not matter what our formula for rubidium nitrate is, because the 6.02 times 10 to the 23rd is across the board, regardless of what you're talking about. So I set up my 0.25 moles. I want formula units, so that goes on top over 1 mole, and I multiply across the top and divide by the bottom, and I got 1.505 times 10 to the 23rd, and those are formula units. Well, if I give you molecules, so right here I gave you molecules, and I want to know how many moles. So it's the opposite setup of the one that we had before. So I take my 4.03 times 10 to the 24th, that's listed first, then I multiply by my conversion factor, which is 1 mole of sulfur dioxide, which is what I'm wanting to know about, over 6.02 times 10 to the 23rd molecules of sulfur dioxide, and so when I multiply 4.03 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd, you get 6.69 moles of sulfur dioxide. So far we've done grams to moles, moles to grams. We've done moles to formula units, and formula units are molecules to grams, or to moles, sorry. And we can combine any of these into multiple steps. The mole is what you have to go through, and we'll do some of those problems in a class. The last thing is dealing with volume. 1 mole of a gas is equal to 22.4 liters of the gas. That is always for right now. So right now, 1 mole is 22.4 liters. So if I have moles of oxygen and I want to know how many liters that is, I'm going to set up my problem so that I have my 0.25 moles. My given is listed first. What I want goes on top, and what I have, the 1 mole, goes on the bottom. So multiplying across and dividing by 1, I get 5.6 liters of oxygen. If I have liters, so I'm given liters, and I want to know how many moles that is, then that means that we're going to have the conversion factor listed opposite of that. What we want is on top. So when I set this up, my 9.32 liters is listed first. My conversion factor, and this is the factor, is what they are equal to. The 22.4 liters, because I'm given liters, goes on bottom, and the mole goes on top. I didn't do this in the previous slides, but what happens is you end up canceling out those units, and you're left with that 1 unit. And we'll talk about that more in class. So that's the basic of the moles, and we'll see you in class.